Okay, today's lesson is on electromagnetic induction. I'm going to do videos of demonstrations first, the notes will be second. Electromagnetic induction is simply a fancy way of saying how do we make electricity. So what I have here on the screen for you, this is called a galvanometer. You can see it measures microamperes and it can go positive and it can go negative. I just have two wires hooked up to it. I'm going to put these two wires on this solenoid. Sort of a big solenoid, but that's because, so obviously there's no electricity being made because the needle is not moving. So I'm going to take a magnet and I'm going to put the magnet inside the solenoid. Did the needle move? Yes, it did. I go in the solenoid, out the solenoid. It's not a very strong magnet. Let's see if my big magnet will fit in there. I think it might actually. Yeah, my big magnet will fit. If I put it in, it moves one way. Take it out, it moves the other. In, out. So to make electricity, this is literally what you have to have. You need a coil of wire, you need a magnet, but it can't just sit there. It has to move. And I can have AC/DC going back and forth. I can go nearby. You can see that even if I go around it, I move my magnet around it, I can make a little electricity. We'll get into which way the electrons flow in a little bit, or where the current goes. Oops, that's, again, if I put magnet in, take it out. If I come on the other end, sorry, it's very attracting. It works, doesn't matter which end I do it on. Most generators don't move the magnets when they make electricity. All right, so the next one you've actually seen in the forces, but I'm gonna reverse it and make it into a generator. All right, so this little device, it's called the St. Louis motor and generator. I'm gonna hook it up back here. When we used it for forces, or for, I'm just trying to get everything out of the way. Come on, wires. We put electricity. As you can see, there's no batteries here. What's here? These are connections that go to the meter. These are metal brushes. Because this is a DC, there's a ring down here that half splits. It's called a commutator. Here's two magnets, and here's the coils of wire. And of course, to make them strong, we always put metal in there. There is no electricity. So if I start to spin it, and I'm doing the running, the moving, look what happens to the needle. If I spin it the other way, it goes the other way. So I'm moving this, I'm making electricity go me. If I don't move it, I make no electricity. In power plants, the coils generally spin between giant magnets hooked up to a movable connection. If you think about this, these two metal pieces are sitting on here, kind of like a bumper car ride, the way it connects to the top, and I can make electricity. Honestly, if I want to make a lot of electricity, I'm going to need a bigger system. Just to show you that this, first of all, is all the parts to a motor, but it's also the same parts to a generator. The difference is what you do with it. Here is just a little motor. I can do the same thing. Instead of hooking this to electricity and making it spin, I can take the axle and spin it myself, and look at the meter. Inside here is a coil. I can actually make a lot more than the others because it's made for it. It's got a good smooth. All right, so that is how we make electricity. How the current flows in those directions is going to be a little bit tricky. So we'll get to the written part in just a minute.